Hello everyone, welcome to DT Studio. Myself Megha from Government Polytechnic ENC department, here to share few ideas on basics of electrical and electronics engineering. Let's look at the references I have referred to prepare today's content. Let's go through the short recap of the previous session. So we had enough discussion on the motors, specifically AC and DC type of motors, as well as DC generators and AC generators. So features of DC motors and as well as applications of DC motors, along with the types of DC motors was discussed in the previous class. So we have seen the DC motors can be of DC shunt type, DC series, or as well as DC compound motor. In DC shunt motor, in order to make armature current high, the field resistor, the field coil which is connected in parallel, that is in DC shunt motor, the reluctance of this coil is made very high so that it draws minimum current and maximum current will go through this armature so that we get enough torque out of this armature, which will be a rotor part of the DC motor. So to achieve this, number of coils as well as the diameter of the coil is, number of coil is increased, diameter of the coil is reduced. In case of series motor, since the same current is flowing through the field as well as armature, so we need a high current to flow through this field so that it reaches this armature. A thick diametered coil along with the less number of turns will be used for the DC series motor. Coming to the compound motor, it is grabbing the advantages of shunt and as well as series. So we have a field element in series as well as shunt. It can be further classified as long shunt and short shunt. Other than this, we have also seen what is a DC generator. So DC generator basically converts mechanical input to the direct current energy. Types of DC generators was also discussed along with the applications where we use DC generators in charging of batteries, lighting purposes, welding generators, etc. Then coming to AC machines, we have seen what is an AC motor. So basically AC motor consumes AC electrical energy at the input and gives mechanical energy at the output. So induction type of motors were discussed in detail, which are asynchronous type of motors. The features of the AC motors as well as the applications of AC motors was discussed. We have also seen what is an AC generator, a dynamic type of AC machine, which converts a mechanical energy into an alternating current type of electrical energy. So this energy is universally used for generation of electrical power is the main application. The generating stations like nuclear power, thermal power and tidal power stations are using these alternators, which are nothing but AC generators. So that's all was discussed in the previous class, winding session on electrical machines. So today, let us try to understand about the passive components. So under this category, we will be trying to define what is an active component and what is a passive component. Some examples for the passive components would be resistors, capacitors, and inductors. We will try to understand each one of them in detail, knowing their specifications, classifications, features, examples, and as well as applications. So let us move to the definition for active and passive. So friends, I think this slide would give you what is a meaning of adjective active and a passive. So the one who is involved actively in the constructive work will be called as active. So similarly, we can have the same analogy for the electronic devices also. So what is an active component? A component which have the source of power or it can amplify and it can supply the power to the other components as well. Then it will be called as an active component. The examples would be an adapter, DC power sources, batteries, etc. In contrary to the passive components, we have those components which doesn't have any source of power or they cannot even amplify, but in fact, these consume the power and also try to attenuate, that is, decrease the signal strength when the signal is passed through them. So it will try to reduce the strength of the signal, then such type of components will be called as passive components. So the examples under this category, friends, will be resistors, inductors, and capacitors, etc. So you can see the images for passive components and as well as the images for active components. Let's look now into the details of one of the important passive component, which is nothing but resistor. So let us watch the video and try to understand. So resistors are the integral part of almost all the boards. These are the basic electrical and electronic components of any circuit. These are one of the passive component. So let us understand what is a resistor, what are the characteristics of a resistor, and what are the different types of resistor. So what is a resistor? Resistor is nothing but a passive component or a passive element which opposes the flow of electricity or the current through it. So friends, you can see the symbol to represent a resistor will be a zigzag line. The symbol to represent a resistor will be like this, or alphabet R written over a rectangular box. So you can see here the resistance unit is ohms, and the symbol used to measure, write the resistance is this one. So it is the inherent property of a resistor to oppose the flow of current, and that property is called as resistance. Look at the circuit here. We have one old DC supply and a resistor is connected across the supply. We have observed a current of 1 ampere flowing through this element. Then it indicates that the resistance of this element is exactly 1 upon 1, which is 1 ohms. So Ohm's law, we have a linear relationship between the voltage and as well as current. So if you try to plot the curve with respect to voltage, applied voltage, the current flowing through the resistor, it is almost linear. And if you calculate the slope of this line, we will get the value for the resistance. So by Ohm's law, we can write voltage to current is nothing but a resistance. But what are the parameters affecting the resistance? So we have the expression R is equal to rho L by A, where rho is referring to the resistivity of the material, L is referring to the length of the material, and A is nothing but the area of cross section. So resistivity of a material is an inherent property of a material. Now we can see a case study here. As we increase the length of the resistor, so as we increase the length of the resistor, you can see here, then definitely the resistance of this material will be more because it offers more opposition to the flow of current. You have increased the length of the material in the second case compared to L1, L2 is greater, and hence the resistance of this type of resistor is more than the resistance of the first. Now, if you go with the second case, while increasing the area of cross section, friends, look here. Look at the area of cross section A1 corresponding to this resistor and A2 as the area of cross section for the second resistor. There is an increase in area of cross section, but what happens? More number of electrons will try to flow through this device, which will be increasing the current flow through the device. Hence, the resistance of this type of resistor will decrease. So what I mean to say here is, as you increase the area of cross section, the resistance value will decrease. That is, the opposition offered to the flow of current will decrease. To conclude, if you want to increase the resistance of a material, increase its length. If you want to decrease the resistance of a material, increase the area of cross section. So these are some of the different types of resistors which are used for specific applications. They do come in different shapes and sizes. Coming to the characteristics of resistor, we have the few important characteristics for the resistor as power rating, tolerance, temperature coefficient, noise, frequency response, and stability. So let us look into each one of this in detail. So what do you mean by power rating characteristic of a resistor? So it is nothing but the product of voltage and current. So we can define the power rating of a resistor as the maximum power that can be handled by the resistor. So we have P is equal to VI. Now if we consider general rating for a resistor, it will be in the range of 1 by 16 watts to 300 watts. And always remember a thumb rule: when you have a resistor used in a circuit, please make sure that the power handling capacity of the resistor is 2 or 4 times greater than the actual power which will be dissipated actually in the circuit. So the rating what you are using for the resistor should be enough high than the actual power that is flowing through the circuit. Now if you consider an example of 5 volt with 1 ampere rating, then that particular resistor will be having a wattage of 5 watts. Now, some manufacturers not only give the power rating, but they also give a power derating curve. So what is a power derating curve? It means that with respect to temperature, the variation in the rated power. So most of the time, these resistors are temperature sensitive. So as you increase the temperature of the ambience, then the power rating or power handling capacity of the resistor considerably reduces. So when you are using it in a circuit, you have to even refer to the power derating curve if your circuit is undergoing different temperature variations. Then the next parameter is called as tolerance. So tolerance is the deviation in the resistance from the nominal value. They do mention in the data sheet, which is given by the manufacturers, as R is equal to 100 ohms plus or minus 1%. So this 1%, whatever has been mentioned along with the nominal value, is called as the tolerance value. It means that the resistance value of this element can vary at max of this much, that is plus 1 or minus 1. Hence, the value of the device will be between 101 and 99 ohms. So the available resistors in the market from different manufacturers have the tolerance limit in between 0.1% to 20%. Let us go to the next characteristic of the resistor, that is temperature coefficient. So it actually refers to the amount by which the value of resistance is changing with respect to the change in temperature. So usually it is measured as the temperature coefficient and in terms of ppm per degree Celsius. That means part per million per degree Celsius. We can consider an example here. Say if the resistance is 100 ohms at 25 degrees Celsius and the manufacturer has given the temperature coefficient to be 50 ppm per degree Celsius. That means 50 parts per million per degree Celsius. Then if you try to use this element or raise the temperature where this element is used by say around 4 degrees Celsius, that is if the temperature is made 29 degrees Celsius, then the value of resistance will be 100 plus this is 50 parts per million. Per million stands to 10 to the power 6. So 50 divided upon 10 to the power 6, you get a value of 0.000050. And what about the variation in the temperature? It is by 4 degrees. So 4 multiplied by 100. So we will get around 100.02 ohms. So it means, friends, the 0.2 resistance, whatever has been added to this nominal value, is due to the variation in the 4 degrees temperature. If the temperature coefficient is 500 ppm, then the change in resistance will be 100.2 ohms. I want to tell you that lower the value of temperature coefficient, better is the resistance. I mean, if you are using a resistance in your circuit, make sure that it has got lower temperature coefficient so that the variation in the temperature will not lead to a drastic change in the value of resistance. I hope the definition for temperature coefficient is clear. Let us move to the next characteristic, which is frequency response. So the behavior of this element, the behavior of the resistance or the value of resistance do change with the drastic change in the frequency. So some resistors are designed for low frequency applications, while some resistors are designed for high frequency applications. So when it is used in the circuit, or if you try to look at the model of the resistor, so the model of resistor will be something like this, friends. When it is a lower frequency, the higher reactance will be offered by the capacitor, and it will be an open circuit, and but this will be a short circuit because of zero reactance offered by the inductor at lower frequencies. Then it will be the only effect of R which is felt. But friends, when you try to increase the frequency, then the reactance offered by the capacitor as well as inductor is not negligible. So they do count for the total opposition for the flow of current. And the other two parameters or the characteristics of a resistor is nothing but noise and as well as stability. Stability refers to the variation in the value of resistance with respect to different parameters, say vibration, it is under force, it is under the different magnetic field, or temperature variation, or humidity variation. So if you want to tell a particular resistor is stable, then it means that the value of resistance should not change considerably with the change of all the other parameters. Coming to the other parameter, you have something called as noise, so which is unavoidable. So the one more characteristic is noise. So we have some noise also encountered due to the property, inherent property of a resistor. So these are the important characteristics of a resistor, friends: power rating, tolerance, temperature coefficient, noise, frequency response, and as well as stability. Hope the characteristics of the resistor is clear. Let us look at the classification of resistors now. So after understanding the definition of resistor, its symbol, unit, and as well as specifications, now the resistors can be of two types. They can be of fixed type or variable type. So under the category fixed type, you have carbon composition type, carbon film, metal oxide film, wire wound, and surface mount type of resistor. So let us look into the details of each of these type of fixed resistors. So we have the carbon composition resistors. So these are carbon particles along with the binder, which is usually the clay which is used. So the characteristics or the features of carbon composition resistor, these are used to withstand high energy pulses, but they have a drawback of poor temperature coefficient, a poor stability, and have high noise with low accuracy. So these are the features of carbon composition resistors. Let us go with the second type. You have carbon film resistor. So you can see the carbon film which is wound around in a helical type of structure. The pitch of this helix can be changed to vary the resistance of this. Ceramic substrate is used over which this carbon film is wound. The features of carbon film resistors will be, so these are of low cost, and compared to carbon composition, these offer less noise. These have low tolerance, used in usually high voltage and high temperature applications. And the value of these resistances from the different manufacturers vary from 1 ohm to around 10,000 mega ohms, that is 10 giga ohms almost. So wide range of resistance values. Coming to the next category, metal film type of resistor. So let us look at the features of the metal film type of resistors. These are also low cost, less noise, good stability, and these are used in high frequency applications. These have got low temperature coefficient for the resistance. The other category of the resistor under fixed type is metal oxide film resistors. So you can see a metal oxide forming the film over a ceramic substrate, and the tin oxide contacts are taken out as the leads to make the connections. The features of metal oxide film resistor will be, of course, these are also cheaper. The noise and stability tolerance, these all are poor compared to metal film. It has got poor temperature coefficient compared to the metal film resistors. That is, a small variation in the temperature will lead to a drastic change in the resistance. Used in high temperatures like high surge applications, power and voltage ratings are better than other film resistors. So these are better in voltage and power handling capacities compared to the other type of resistors. The next category is wire wound type of resistors. So you can see a resistive wire is wound around a ceramic type of material. The features of this type of resistor will be, these are highly accurate, these have got low temperature coefficient, used in high power and high precision applications, but these are not suitable for high frequency applications. The last category is surface mount technology resistors. So as you can see, these resistors are directly fabricated, mounted on the printed circuit boards. So these are called as SMT type of resistors. The features or the constructional view of a SMT type of resistor will be, you have a ceramic body and you have metallic leads forming the contacts to solder them on the boards, printed circuit boards, and you have a thin resistive film over which an insulating layer is deposited to protect the device. The features of surface mount technology type of resistor. Okay, of course, these are costly, but these are highly accurate and smaller in size. We will see all these again in detail. So hope this video was clear to explain you the definition of resistor, the specifications of resistors, classification of resistors. To list the basic introduction about resistor is, it is the most basic electrical and electronic component. It is one of the passive component. As it dissipates heat energy and it consumes power, it opposes the flow of current in the circuit, and the property by which it opposes this flow is called as resistance, and the amount of opposition is measured in ohms and it is called as its ohmic value. So these are the basics of a resistor. Now, application of resistor. A resistor can be used as an electrical load. It is a current limiting device, or it can divide the voltage. So it works like a potential divider, or it can be called as a biasing element. Along with the capacitor, it can work like a filter, or it can even work like a timer. It is used as a relay coil in thermal type of relays. And of course, the volume, brightness, and tone controllers, what we have in our radios and TV sets, are made up of these resistors. So hope the application, the list is still not, this is not the limit, the list goes on. Some of the few applications where resistors are used are listed here. As understood from the video, the specification of resistor, the important specifications will be power rating, tolerance, temperature coefficient, frequency range, noise, as well as stability. So to repeat, power rating is nothing but the power handling capacity of a resistor. It is the product of voltage and current. Tolerance is the change in the resistance value from the nominal value. So it is given by the manufacturers in percentage. Temperature coefficient is the variation in the resistance with respect to the change in temperature, usually given as ppm per degree Celsius. Frequency range corresponds to the operating frequency for the resistance, and noise is the unwanted distortion we are getting due to the introduction of a resistor in a circuit. And stability, the capacity of a resistor to hold its value to a designed value irrespective of the variations in the humidity, magnetic field, or the force. So these are some of the specifications. Let us now go to the detailed classification of the resistor. As we have seen from the video, The resistors can be broadly classified into two types. Friends, the first category is fixed resistors and the second category is the variable type of resistors. So fixed resistors, the name itself indicates that once it is fabricated, you don't have any option to change the value of resistance of these devices. So fixed resistors are the one which have the value for resistance fixed by the constructions. So in that category, we have wire wound type of resistor, carbon composition, carbon film, metal film, and metal oxide. Coming to the contrary, we have a variable type of resistors. So these resistors can be either of two types. They can be continuously varying type resistors or they are preset or adjustable type of resistors. So continuously varying type of resistors are those whose value can be varied in small instance. Whereas adjustable or preset resistors, you have some preset values for those resistors. You can tap or you can select any one of those set values for the resistors. So friends, let us look into the details of these types of resistors. So the first category under the fixed type of resistor is wire wound resistor. So this is these all types of resistors what have been listed here under the fixed type. Basically, they vary in the construction. They differ from each other in the aspect of construction. So let us look into the details of these fixed type of resistors. So the first category is wire wound resistor. So you can see the image here. A nichrome wire around the ceramic core is wound in the form of helix. And you have a ceramic sealing over this setup and you have the contacts made of metal which will be serving as the connectors. Now, to know the features of this wire wound resistor, these are manufactured by winding resistance wire over an insulated rod or a tube. And a thin insulation is coated to avoid the short circuiting between the turns. So between the turns, you have an insulating coat. The entire winding is coated with cement or vitreous enamel to provide the external protection. And these are capable of handling power from 1 watts to 5 kilowatts. And of course, these have a lower frequency range of operation. That is, you can use these wire wound type of resistors for a frequency up to 200 kilohertz. What about the temperature withstand capacity of this? So these work fine in the wide range of temperature, that is around minus 55 degrees Celsius to 375 degrees Celsius temperature. So friends, these are the features associated with wire wound resistor. So look at the power rating and as well as temperature rating, they are enough high, but the frequency of operation is limited to 200 kilohertz. Now let us talk upon the second type of fixed resistor, which is a carbon composition resistor. So friends, you can look here. The mixture of carbon particles is banded with the non-conducting type of material and you can see the colored bands or coats. It is molded on a case and you have leads embedded into this composition which will be serving or helping for us to connect in the circuit. So a fine powder of graphite and lac are mixed together with a synthetic resin and it is pressed onto the thin rods or the slugs. The tinned copper leads are embedded here and here. They are embedded at each end of these rods. These provide or you are getting the carbon composition type of resistors in the range around from 1 ohm to 20 mega ohms. And the power handling capacity of these type of resistors is around 1 by 8 watts to 2 watts. And these have a temperature operating range from minus 50 degrees Celsius to plus 50 degree 150 plus 150 degrees Celsius. And of course, these have a drawback that they are dependent on the humidity and temperature. So they are humidity sensitive and temperature sensitive. So friends, whenever there is a quite change or the variation in the ambience humidity and as well as temperature, then we may get the deviation of this resistance from the nominal value by a larger amount. Hope the carbon composition resistor is clear with you all. We can go with the next type. So carbon film resistor. So friends, look here, the carbon film resistor internal diagram. You have even color bands for this, helix type of structure, the substrate, and the insulating between these helixing structure, as well as you have a termination lids for connection. So these are basically manufactured by depositing a thin film of carbon on a ceramic rod and then spiraling. These are available in the range 10 ohms to 10 mega ohms. And these have a power capacity or power rating of quad watt, that is 1 by 4 watts to 2 watts. So the power handling capacity of these resistors is pretty less, but these are very cheap, come small in size, and hence lighter in weight also. These are very stable at the high frequencies. You can use these in the megahertz frequency range also. And the operating temperature for these resistors is from minus 50 degrees Celsius to plus 150 degrees Celsius. And these have a lower temperature coefficient, meaning that whenever there is a drastic change in the ambient temperature, then the variation in the resistance is not that high. So these are some of the important features of carbon film resistor. So the next type is metal film resistor. So friends, you can see here it's not that different from the carbon film. It has been replaced by a metal here. So nickel chromium alloy is used. You can see the previous one. It was a thin film of carbon which was around a ceramic rod. But now here you have a nickel chromium alloy which is serving as a metal film, is placed in a highly evacuated chamber. Then the leads, connecting leads of the copper are soldered to form the leads at the ends. And this entire assembly is encased in an epoxy resin to give the protection to the external circuit. And then the color bands are put over this device. And these are available in the range of 0.1 ohms, that is 0.1 ohms to around 10,000 mega ohms. And these can handle a power up to 1 watt. And these are used in high frequency applications. These have got lower temperature coefficient and as well as minimum noise. So the advantages will be high frequency, low temperature coefficient, and minimum noise. But you need to compromise on the power rating. You have a very small power handling capacity for these type of resistors. Let us move to the next type, the metal oxide type of resistor. So here the oxides of tin and antimony as well as boron are sprayed over a glass or the ceramic rods. So here the construction differs from the previous two by fact that the tin oxide, antimony and boron are sprayed over the glass or the ceramic rods at around temperature of 1200 degrees Celsius. Then the connecting leads are fixed to the ends for this oxide type of resistor, and you have a protective coating of epoxy resin which is around this, and then the color bands are added to the surface. These are available in the range 10 ohms to 10 mega ohms, but the power rating for these resistors is very low. So it is around 500 milliwatts power rating for these type of resistors. So hope the fixed type of resistors, all the five, what I have discussed now are clear. Wirewound, carbon composition, carbon film, metal film, and metal oxide. So all these resistors, friends, have got some advantages as well as disadvantages. So it depends on the designer to select an appropriate resistance to fit into his specific application for which he is designing the circuit. Now, how to identify the values of these fixed type of resistors? So we have two techniques. One is resistor color code and the other one is resistor letter codes. So we can use these techniques to find out the value of the fixed type of resistors. So usually the fixed type of resistors have color bands on the surface. So using these color bands or referring to these color bands, we can easily identify what is the resistance value of that particular resistor. So friends, this table will help us to know the value of such type of color coded resistors. You have black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, or none. So these colors will be printed on the resistor in the form of bands. And these colors correspond to the specific digits. So as you can see, a specific number has been written in front of each color. So black corresponds to 0, brown corresponds to 1, red corresponds to 2, orange corresponds to 3, yellow corresponds to 4, green corresponds to 5, blue corresponds to 6, violet corresponds to 7, gray corresponds to 8, and white corresponds to 9. Coming to this is the digit corresponding to each color. And if you want to write the multiplier corresponding to this each color, then you can just raise these digits to the power of 10. So friends, look here, it is 10 to the power 0 here, which is nothing but 1. Then this is 10 to the power 1, 10 to the power 2, 10 to the power 3. So yellow corresponds to 10 to the power 4, so on. But the gold corresponds to 10 to the power minus 9 and silver corresponds to 10 to the power minus 2. So this is 1 by 10, this is 1 by 100. The 5 bands out of these all are unique. The gold, silver and no band usually serve information on the tolerance range for a resistor. Other than this, you have brown, red, green, blue and violet also giving the information about the tolerance. So might be feeling difficult to remember this, but just see the digits are numbered from 0 to 9. You can remember the first alphabets of this sequence. So usually we do frame a sentence having these alphabets, like B.B. Roy of Great Britain has a very good wife. So B.B. Roy, R-O-Y, of Great Britain, GB, Great Britain, has a very good wife, VGW. So friends, you can remember in this way, black, brown, so it is BB Roy of Great Britain has a very good wife. You can expand on this. Black, start with the black and you can see it is going from the darker color towards the lighter colors. Starting with black, we are winding up 9 for the white. So black, brown, red, orange, yellow, green, blue, violet, gray and white. So let us try to understand it in a better way, how these color coding technique is helping us to find the value of a resistance. Now you have the resistors in the form of 4-band and as well as 5-band. So a 4-band code will be, you have the color bands which are in 4, 1, 2, 3 and 4. Whereas 5-band code, you have 5 different color bands on the resistor. In case of 4-band code, the first color corresponds to the first digit, the second color corresponds to the second digit, and the third color corresponds to the multiplier, and the fourth one, the last end band, will be giving us the information about the tolerance. In case of 5-band code, friends, the first 3 color bands will be giving us the first, second, and third digit of the resistance value respectively, whereas the fourth band will be giving us the multiplier. The fourth band will be giving us the multiplier information, and the last end band will be giving us the tolerance. So when you have 4-band code, the first 2 colors will be giving the first 2 digits followed by multiplier and tolerance. In 5-band, the first 3 digits are obtained by the first 3 color bands and then followed by a multiplier and tolerance. So as I have told, brown, red, green, blue and violet are special colors which are also used as the tolerance codes or tolerance bands. Let us take some examples to find the value of these fixed type of resistors. So friends, look here. Now looking at the image, you can easily tell it is a 4-band code type of resistor because you have 3 colors along with the tolerance, 4 bands. The first color, if you try to look, it is a yellow. Second is violet. Third is orange. And this is the tolerance band corresponding to gold. So if you want to find the value of this resistance, So go back to the table. So you have colors here, yellow, violet, and orange. So you can look here. Yellow is 4, violet is 7, and orange is 3, right? So here we can, yellow is 4, then violet is 7, orange is 3. And what about gold? So friends, you can see it is 10 to the power minus 1, or it is 5% tolerance. When it is used as a tolerance band, it is a 5%. So the end band is always a tolerance band. So this here, it is corresponding to 5% tolerance for gold because of gold. Now, what does these three indicate? We have seen it in the previous slide. In case of 4-band code, the first 2 bands, color bands, will be giving the digits, and the third one is giving the multiplier. So let us try to do that here. So the first one is the first digit, 4, and the second one corresponds to the second digit, 7. The third one, in case of 4-band code, corresponds to the multiplier. So it is 10 to the power. Now, what is the color? Orange. So orange corresponds to 3. So I have written 10 to the power 3. And plus or minus 5%. This is because of the gold, which is the tolerance band here. So friends, the resistance of this resistor with these specific colors given here will be 47 kilo ohms with 5% tolerance. Similarly, we can take up one more example here. So look at the color bands, identify the color bands. We have green, red, gold, and silver. So friends, this is a 4-band resistor. But the third band, you have gold serving as the third band here. And as well as the silver is the end band or the tolerance. So try to look at the table. We have colors green, red, gold. Green corresponds to 5. Red corresponds to 2. So green corresponds to 5. So let me write that here. Green corresponds to 5 and red corresponds to 2. Now here the third band used is a gold. So even gold can be a band. It can contribute to the multiplier by 10 to the power minus 1. And silver is the tolerance band. So you have a tolerance of 10% for silver. So let us try to now apply that here. So gold is corresponding to multiplier 10 to the power minus 1, right? And what you have? Silver tolerance, which is 10%. So now we can write the first digit is green, corresponds to 5. Second band is red, it corresponds to 2. Then third band is a multiplier, which is gold, and it corresponds to 10 to the power minus 1. And the tolerance is 10%, so plus or minus 10%. So it is around 5.2, right? 10 to the power minus 1, it means divided by 10. So 52 divided by 10, it is around 5.2 plus or minus tolerance of 10%. So it has a resistance of 5.2 ohms with 10% tolerance. So I hope the examples are clear. You might have understood how to calculate the resistance given the color codes. You have a set of problems again here. Okay, we can take one in this because it is not 4-band, it is a 5-band here. Okay, so look at this example. Look at this example, friends. We have 5 bands, orange followed by orange, then black, then brown, then violet. So it is a 5-band. So when it is in 5-band, we have first 3 colors defining the digits, then fourth will be the multiplier, and fifth will be the tolerance. So now let us look at the first 3 bands, which are orange, orange, and black. Let's go with our BB Roy table. So we have orange corresponding to 3 and black corresponding to 0. Brown corresponding to 1. So let us do that here. So orange corresponds to 3. Again followed by orange corresponds to 3. Then black is 0. Then brown, the fourth band is the multiplier. So what is the factor multiplier for brown? It is 10 to the power 1. So the multiplier for this will be 10 to the power 1. And you have a violet as the tolerance band. Friends, look here. The tolerance is not gold or silver. It is violet here. So look at the tolerance of violet. So what tolerance for violet is, under tolerance, you have for violet as 0.1. So let me now try to write the value for resistance for this particular example. So it is first digit 3, second digit also 3, third digit is 0 corresponding to black, multiplied by the multiplier fourth band brown, which is corresponding to 10 to the power 1, and you have a tolerance of 0.1. Okay, so the resistance of this is 3330, because 10 to the power 1 is 10. So when you multiply 330 by 10, it will be 3300 ohms plus or minus 0.1. That is, the variation for this type of resistor will be 3300 minus 0.1 to 3300 plus 0.1. You can even write this 3300 as 3.3 kilo ohms. You can use a prefix kilo to eliminate the number of zeros which are coming here. So you can write 3.3 kilo ohms plus or minus 0.1. Hope the examples were clear for you. You have understood now how to find the resistance given the color codes, whether it is a 4-band or a 5-band type, right? So a few more examples have been put up here, but let's go with the second technique. It is based on resistor letter codes. So here some prefixes are used for the multiplication factor, like you have 4R7. So we don't have the color bands on the resistor, but you have some code written on the resistor, like 4R7. So it corresponds to the alphabet, usually a decimal point, and it is around 4.7 ohms. 4.7 ohms. When it is 5K6 written on the resistor, then it is 5.6. This K is serving the place for the decimal and as well as the prefix for the unit. So 5K6 will be 5.6 kilo ohms. Similarly, 6M8 will be 6.8 mega ohms. So other than this, sometimes it is followed at the end. Like at the end, they do write 6M8J. So the last alphabet are used for mentioning the tolerance. So some alphabets like F, G, J, K and M are added with this letter code to mention the tolerance of that particular resistor. So when it is alphabet F, it corresponds to a tolerance of plus or minus 1%. When it is G, it corresponds to plus or minus 2. When it is J, it is plus or minus 5. When it is K, it is plus or minus 10%. And when letter M is at the end, okay, when it is at the end, it corresponds to 20% of the tolerance. So this is also one type of technique to identify the resistance of a given resistor using letter codes. Hope both the methods, whether it is a color code method or a letter code method, we can find the resistance of the resistor. It's clear. We shall proceed to the next category, which is variable resistors. So these resistors vary their resistance value, or they vary the opposition offered to the current. Either it can be in the form of continuous variation or in terms of steps. Hence, these type of resistors provide different opposition when used in the circuit. So the resistance value of these resistors can be varied in different ways. So we have different type of variable resistors. So let us look at the classification of variable resistor. So these can be of continuously variable type or adjustable preset type. Under continuously varying type of resistors, they can be either potentiometers or they can be rheostats. In case of preset or adjustable, you have decayed resistance boxes, thermistors, and varistors. Let us look into the more details of these type of variable resistors. So the most popularly used variable type of resistors are potentiometers, rheostats, thermistors, magnetoresistors, photoresistors, humistors, force sensitive resistors, and so on. So let us briefly understand what are these variable type of resistors. Coming to the first one, potentiometer. So it consists of some three terminals. So you can see here in the image, you have three terminals. Two terminals are usually fixed and there is one terminal which is free to move. And this is called as wiper or the slider. So as you keep on moving or sliding this wiper over the entire length of this resistance, so the opposition offered by this will change, or you can tell the resistance of this element will change as you move or as you change the position of the wiper along this material. So this type of variable resistor is called as a potentiometer. The next category is rheostat. So the word rheostat itself has been comprised of two Greek words. One is rheo and the other one is statis. So it is a current controlling device or a steam controlling device, the meaning. So this rheostat will be controlling the flow of current flowing through it. So even here we have two fixed ends and you have one wiper. So as you keep on sliding this wiper over this rod, so it will be trying to change the value or it will be trying to select the number of windings here present. In fact, controlling the resistance of this device. So this is also one of the popularly used in most of the academic science labs, rheostat, which is a variable type of resistor. The third category is a thermistor. The word itself indicates thermal plus resistor. So these resistors are sensitive to temperature. So whenever we have a variation in the surrounding temperature, the resistance offered by these elements will do change. And in fact, they do change the current flowing through them also. Hence the name thermistor. So under this, we have two types again, NTC and PTC. We will see them in the next session. The one more type of variable resistor is magnetoresistor. So the name itself indicates magnetic resistor. It means that whenever the magnetic field or whenever the magnetic strength applied to this type of resistor is changed, then the value of this resistance will also change. It means that if you are trying to place these resistors in a magnetic field, and if the strength of the magnetic field is changing, then these devices offer different opposition to the flow of current. That is because these are sensitive to the changing magnetic field. Next type is photoresistor. The name itself indicates photo corresponds to light and resistor. Okay, so whenever you have a light energy applied to this photoresistor, then the resistance of this device or a resistor will change. As the intensity of light comprising of photons will vary, it will change the resistance of these type of resistors. So it is called as photoresistor or even it is called as light dependent resistor, that is LDR in short. The next one is humistor. So the name is comprised of two words, humidity plus resistor. So it has come with the concept that whenever the humidity of the environment or the surrounding air will change, then the resistance of this type of device will also change. It is an image of some China developed humistor. So here the resistance of this device will change when the humidity of the surrounding atmosphere will change. So it is basically a humidity sensor. It can be used as a humidity sensor. hence the name humistor. It is also a variable type of resistor. The next type is force sensitive resistor. So these resistors are force sensitive, or they are dependent on the applied force. Whenever the force applied on these resistors do change, then they offer different resistance to the flow of current. These are usually employed as force sensors or pressure sensors. In short, they are also called FSR. I hope force sensitive resistor is clear. So looking into the more detail of a potentiometer. So potentiometer consists of three terminals. Among that, two are fixed and one is changeable or free to move. The two fixed terminals of the potentiometer are called as track, and the one which is free to move is called as wiper, or even called as the slider. So this wiper or slider will be moving along the resistive track to change the resistance of the potentiometer. So it is changed when it is moving over the resistive path. So we can stop at this point, friends, today. We can start with the detailed descriptions about the potentiometers and different types of potentiometers, rheostats, varistors, thermistors in the next session. So I hope what has been covered today is clear with you all. If any doubts and queries, you can mail me to my account. That's all for today. Thank you.